we're thinking beyond blockchain.
This is the noob's perspective.
Can a person have duplicate IDs?
So all of this you can kind of work with today in Voyage. So even before you go to the JS SDK and stuff, you can go today to MOI Voyage. What's happened here? Yeah, so like I was saying, so it's very easy to start developing on MOI Protocol. So even before you open the SDK and start writing code, you can head over to Voyage, which is kind of our explorer, and you can log in, and our documentation, everything is available from here. And you can kind of, it's like an explorer, you can see all the latest SRAX and transactions running on the Babylon testnet, right? And if you want to make RPC calls from here, you can just like head over to the RPC section, choose the RPC method you want, and then fill in the input, and you can make the RPC call directly from here.
Okay.
So even before you start developing on the thing, you can just play around once you log in and you have a thing. So for RPC calls, you don't need a thing, but when you want to do RPC call and then to send interaction, that requires signing. So for that, you need to be logged in, right?
Okay.
So for this, you need to be logged in. So the login will sign with IOME, and you'll be able to have a wallet that can sign the interactions when you send it, right?
So you're calling transactions as interactions?
Interactions. We don't have the idea of transactions. We have interactions because there are interaction types. Everything is about participants. It's a scale up on that. So everything for us is a fundamental shift, right? Blocks become tesseracts, chains become lattices, transactions become interactions. State becomes context. Everything like goes up one level. So yeah, so the RPC calls can be made here. You can also do logic calls also from this itself. So if you knew the logic ID you want to talk to, you can deploy that here. You can just the logic ID is slightly more than the address. We'll go into what that means. Okay, so let's go into that. So developing on MOI is so simple. You can use MOI Voyage to get started, everything. So there's the next part. So for assets, obviously the interactions we support today are the ones in purple. The ones which are not purple are not yet supported. They're still in development, right? So you can transfer asset between participants. You can create a new asset. You can mint and burn the supply of an MA 0 asset, right? And we don't currently support lockups, approve and revoke, but they're currently in development, right? Logics in MOI are very similar to smart contracts, but they're capable of more. So when I refer to logics, I think of like smart contracts are a certain paradigm. For us, the next paradigm is P2P logics. And that's a whole new paradigm of the way logic. Or interaction execution in our case, right? In EVM, the EVM is responsible for transaction execution as well as the code execution.
Yeah.
Right? So it has to verify the transaction, pay the gas, do all that work. It has to create the block, everything the EVM is responsible for. In our case, the code execution is handled by independent engines. So the interaction can be handled by ISM, but the exact logical code alone. So that's why we have all these objects, right? So things like assets, things like files, they don't need to come to the PISA at all. Only when we talk about logic execution, we can go to a particular runtime. Okay. And today, the one runtime we have is PISA, but we have two more in the design, which is Meru and Hanoi, right? Each of them capable of different types of execution. So like I said, so we can support multiple execution runtimes. So PISA is designed to be a traditional contract execution layer. It's a single-threaded system and all. Meru is WASM-based, and Hanoi is meant to be multi-party compute. Right, so these are just some of the paradigms we're opening up in terms of execution. And the other part is logics in MOI and P2P logics generally also support multiple state paradigms. So you take an Ethereum logic, like a traditional smart contract, the only thing you have is the contract has some state internally. And you store everything in the contract state, right? In our case, we have two types of state paradigms, and you can also be completely stateless, right? So your logic can be completely stateless, which means your logic just becomes pure code on the protocol. And if it's purely code and has no state, you can use that just for simple code execution, maybe for cross-contract calls, some reason like that, right? But the beauty is now the persistent state is like your contract state. Logic, it's state that is associated with the logics account itself. Meaning, every time you want to change the state, the logics account needs to be locked into the context, into the crisis, all right? And if it's an ephemeral state, the state does not live on the contract. It lives on the participant. Meaning,
I'm not actually getting this.
It's a little bit shaky. Like I'll open this up a little.
So before you get into this, I wanted to ask you, like when you said the ISM is only controlling interactions and then that, compute is different. Does that mean like some nodes might only be running compute, some nodes
some nodes can opt out of computing PISA's logic.
Okay.
So some nodes can say I'm only a PISA executor. Some nodes can say I'm a PISA and mirror, right? And depending on the kind of nodes they'll either be able to support certain executions or not.
Okay. And this will decide which node is going to come into this context.
Of course, that determines that because they need to. So if I deploy a PISA logic, then I need nodes which are going to compute PISA to be in the context. Otherwise, no point.
Oh, but like now this allows like these machines to like almost pick their level of compute that they want to come in.
We can do that all the way. Like how many accounts you're holding, whether you're a storage node or not, whether you support file interactions, whether you support asset interactions. Every operator can choose what level of involvement they want with the thing, and affects their incentives. So they can choose to do.
So there's no standard like two kinds of full node, half, whatever.
It's extremely flexible. Context aware there also. You can have a lot of customization along the line, right? So the whole perspective of the MOI protocol is always about personalization and context-aware behavior, right? You want the protocol and the nodes to able to have multiple types of behavior to really have that enterprise-level expressibility. But the point, enterprises, what they really need is not stable. It's not just that they want high transactions per second. That's not the purpose. What they need is compliance and legal flexibility, right? They need your protocol to adjust in ways that make sense for them compliance-wise.
So run a mainframe, run a Raspberry Pi, and both of them could be doing different things but still contributing to the network.
Exactly. So you can run a supercomputer that runs 10,000 cells in a virtual clusters, or just run a Raspberry Pi with a single virtual cluster and just make some money off it. We can run a protocol from a smartwatch all the way to a supercomputer.
The code for every runtime is
the exam code. The same Go code can run on both the smartwatch and on the supercomputer, right? So the network is virtualized in that sense. But anyway, so you asked about this persistent state and ephemeral state stuff, right? So one is, let's say I'm stateful. So here I'm using execute because this is an outdated structure, but it's actually IX logic invoke, right? So if it's a completely stateless logic, notice that this is just the code. There's no state associated. So I'm just making a call.
It's a pure
logic. It's a contract, just pure functions.
Yeah, pure functions.
Okay. And for example, if I abstract that, move to a persistent state, there is a contract and there is some state associated.
Okay.
So whenever you see the box, right, it means that that account
is having a state.
That account is locked in the context.
Okay.
See that locked context on top here. You see this? It's a locked context. The gray box means for that interaction to occur, that context has to be locked.
Okay.
For this, I don't need the logic's context. There's no state.
Yeah.
But in this case, there is a state in the logic, so I need the context. But now here's the beauty. If I go ephemeral, the state is sitting on the participant side.
Okay.
Right. So every time the participant interacts with the contract, they bring state into their system. So every participant comes with different data.
Yeah.
Same state structure, but different data. So the logic never has access to its own internal state. So it does not need a context lock.
Yeah.
Which means it's free to, meaning 10,000 interactions can go through the same logic without needing to sequence them.
Okay.
Because there's no context lock on the logic. 10,000 users can talk to the logic.
Same contract.
Yeah. Without needing to be sequenced. Because there's no context lock on the logic. Logic is just code.
Right.
Right, because the state management is on the participant side. The state is modified in the participant. The same code is modifying 10,000 different participants in different ways based on what the data is.
But this contract can also have the state, right?
That's what the persistent state is.
Okay.
So there is the model where you can have both. A logic could have a state and an ephemeral state and a persistent state, and that could also be involved.
Okay, fine.
So these diagrams are quite complex. I won't go too much. Then they're not fully ready. I just wanted to give you a sense of what they look like. But the idea is that persistent state is your traditional contract level state, and ephemeral state is participant owned state.
Okay.
So the moment
this ephemeral state is a new feature in this.
It's part of peer-to-peer logics. The idea that we use ephemeral states for supporting cross-contract calls, communication between contracts. So like my contract can write some information into my ephemeral state, and your contract will read that state.
Okay.
And it can learn things. It cannot modify the ephemeral state of another logic, but
it can actually read.
I can read that. So if I'm a guardian, right? If I'm a validated guardian and I want to know how much stake I have, let's say I am just some random logic. I want to know, are you a guardian and how much stake you have? Instead of making a cross-contract call to the guardian contract, I can have the guardian contract be fully ephemeral. The guardian contract wrote to my account that I am a guardian and I have, say, 32 MOI in stake. So that every other logic can read the data from my ephemeral state. So the state, I am carrying my state with me wherever I go.
Yeah. So it will not have to make a call to the contract to get the state.
Correct. Because cross-contract calls for us are very expensive. Because we're not running in the same block. Because if I want to do cross-contract call, I need to pull a third participant into the consensus.
And gas costs
are higher because I need to pull another context into the consensus set, sir, because not just two participants. I'm bringing a third participant context set. So, and I can't do that in the runtime. I need to know a priori who you're going to call. When the consensus is formed only, I need to have the context set, right? So this is an super efficient way to build really scalable applications, right? So for example, one of the applications that you can think of for building this, there are two implications for this. One is data privacy and the other is concurrency, right? So because of the lack of central locking, I can have the same logic being responsible for driving thousands of interactions simultaneously. Right? I write a piece of code, deploy it, 10,000 people can use that code without needing to worry about which block they're going to be, will I get involved or not, who in what sequence, none of that. They're all independent because each of them have their own ephemeral state that the logic is independently managing. Then there's privacy component to this also, meaning unless I elect to participate with that logic, the logic cannot just manipulate my data as it wishes.
Yeah.
Right. Obviously, the way the data is accessed is different because it's available in the node state. But the fact that my data is safe and it's only managed and modified when I give access to the logic, that's great. I can choose to never talk to the logic again. My data is right. So and the example I have here is of like a cab hailing service like Uber, let's say, right, where Ganesh is an account, Manish is an account, and on the cab hailing logic, I have 4 methods. Okay, one is an invocable method, which are like your function calls. So I have a book ride and I have an accept ride method, something like that. Just very basic idea here. There's a more solid architecture we have.
Yeah.
Then I have an enlister, which is like a constructor. So, but we have two types of constructors: enlisters and deployers. Okay. Deployers deploy persistent states, and enlisters deploy ephemeral states.
Okay.
So an enlister is basically when I first join this contract, when I want to talk to this contract now onwards, I need to first create an enlist ephemeral state. So I need the logic needs to construct its state on my right. So I need to go and say I'm register me as a hailer.
Okay.
So when I go register myself as a hailer, I get this state constructed on me.
Okay.
And if I go register as a driver, that state gets constructed. Notice that
it is in my state.
It is in my state tree,
and that is being written by this.
The contract wrote that date into it.
Okay.
State into it. So contract has no state, but the contract has logic
because
for writing the state.
This one is ephemeral. That's why.
It's ephemeral. So both of those are enlisters. They can directly write into the logic, right? So once now if I'm Ganesh and I registered myself as a hailer, I have the role object is the same, the journey object is the same, the verified is true, same, it's again Boolean, and inside data I can have some random object. That object can be based on, if I'm a hailer, I want information like my emergencies data, my history of journeys. But if I'm a driver, I want information like my vehicle information, what is my current job, stuff like that, right? So I might have data. So I can build a full Uber. We actually designed, this is a very primitive description, but we can build a complete ONDC based Uber on blockchain.
That is because of this
ephemeral state idea. Yes. Yeah. So one of the things that P2P logics and ephemeral states and these things open up is real world use cases that could never have been built in any other blockchain. They can actually be built on this. You cannot build ONDC today on blockchain.
That is true.
Impossible.
Some kind of off-chain computation, off-chain logic,
off-chain
and
compute, some kind of malicious trust.
You
got to do a lot of compromises.
The centrality would come into it. So correct. It's not.
But we remove that by but the problem is blockchains today are not actually decentralized.
Exactly.
A ledger is also decentralized in some sense. It just happens to be distributedly computed, right? To really be decentralized, you need to have actors and you need states and peer-to-peer data. Every object must be peer-to-peer managed. Everything must be participant-driven. Right? Only when participant-driven is just another word for peer-driven. Right? If you're building a peer-to-peer protocol, you need to be the first thing you have to put is the peer. Right? Everything between the peers have happened. So once you open ephemeral states, this is the kind of implications, the kind of use case you can build are just amazing. Right? Today, we don't support ephemeral state in the Babylon chain yet. It's not an open feature. It's expected by the end of the year. So today, you can deploy a persistent state logic with deploy, and you can make calls to invoke. Okay. There are other interactions for enlisting. When you want to join an ephemeral state logic, interact basically means you can use a multi-participant call. It's like almost like multi-sig, where I can make an interactable call to multiple participants from me. And all of these participants get involved in the logic. The logic has access to multiple participants it can manage. In invoke, it's always one participant and the logic. In interact, there is multiple participants and a logic. And there is a sender and there are other participants, right? And then upgrade. This is the beautiful part. We support in-protocol upgradability.
Okay.
Which is why I have a logic ID, not a logic address. The address is a part of the logic ID. And every time you upgrade the logic, it creates a new edition on that address.
Okay.
That the new edition also sits in the same address, same account. So there's no new context object now.
Just an ID.
It
gets added.
updates a new ID. So it's in the same object. The state just propagates over to the latest version, but it gives you a new logic ID when you upgrade. So, but if you access a logic through its address, you'll be able to use the latest version directly. And you cannot use an older version of the logic once it's upgraded. Once it's upgraded,
So ID is like versions.
the ID has more than the version. ID has a logic address. What is the current version? Whether that's persistent ephemeral states. Does it support asset logics? So there are some. If you want to, because perspective than an object-oriented polymorphism perspective, right? Then it's a statical type programming language, not like Solidity in that sense. It's a high-level programming language and it's indent-based, so it looks very Pythonic, right? So we don't do curly braces, we use indents. And it's a programming language that is prioritizing readability, auditability, and safety. So the purpose and the goal and why we set out to build Coco in the first place is obviously we've introduced a whole new paradigm for the way code is executed in the protocol. But it's also important now that we have a language that's able to express that same thing for the developer. Right? Developer needs to have access to information like the interaction, participant, context. These things have to mean something down at the programming language. When you're transferring assets or you're managing funds, you need those things to have some level of understanding of the language. So we decided that a whole new programming language with a syntax structure that was more safe, very readable. And my goal always is that if you're building code for the blockchain, it's not just important for developers to have power, it's also important for auditors to have specificity and clarity. Because if an auditor cannot prove your code is safe, then there's no point, no value for your smart contract. And it's also important for other applications or just end users to know what your code does. So the more human readable your code is, the more easier to understand it is, the more easy it is that people will trust your code.
That's true.
So I wanted to add the programming language needed to have that level of easiness to understand, easiness to find security faults, and impossible to make simple safety mistakes. A simple example of that is you cannot perform an overflow addition. Right? If you did 5 minus 10, right, and if you did 5 minus 10 just and try to catch that into uint 64, it will basically throw an exception that you can catch.
Yeah.
So, and the runtime also favors using try-catch exceptions as a way to manage state management. For example, for managing control flow. So, for example, if you're trying to verify whether someone has enough balance, generally in Solidity, you would verify do they have enough balance, and then you do the subtraction.
Yeah.
Right? In our case, the recommended flow is do the subtract. If an exception occurs, throw an insufficient balance request. Error. So exceptions in PISA and in Coco, when they propagate to the runtime, we have exceptions which are reversion exceptions, but you can also throw exceptions which are not meant for revert. They're just meant to be signaling failure. And those will still be recorded in the blockchain, and there'll still be an interaction in the Tesseract for that. But it will basically say failed transaction. And it'll have an exception code that you can use to error code and figure out that it's failed. So the transaction is still valid in error state. Right? So there are soft errors and there are hard errors. Hard errors are used to revert state all the way, and there are soft errors which are used to just indicate failed conditions, right? So then Coco is a programming language that we built for all kinds of stateful runtimes, right? So it's not just PISA. Today, Coco is designed for PISA, of course, but it can also work for Meru tomorrow. It can compile for Hanoi. It would one day compile for even the EVM it can compile for. Obviously, if you're compiling for EVM, you cannot use ephemeral states and all.
Yeah,
right?
yeah, that is
If
true.
you just build a state persistent state, that's an EVM that will compile for Ethereum also. Right? So yeah, but it is primarily designed for building logics on MOI and P2P logics in general. Right? So I just went into why we need a new programming language and how Coco solved these problems. We tried our best to write a syntax that kind of helped address these things. And it's a programming language which has very strict rules around how you manage state and storage. And this context-oriented programming model is the idea that things like assets or things like logics or even participants, they're all unique characters. Right? They're not just variables or copies of variables. So, for example, an asset cannot have multiple references in the system. When you use an asset inside Coco, Coco will refer to that asset as a unique object and will not allow multiple references to those objects. Right? Cryptocurrencies, NFTs, those are unique objects that cannot just be copied or have pointers to them and stuff. Right? So, to support obviously all this model, you need a virtual machine runtime that supports that. So, PISA is a register-based VM. It's not stack-based. So the reason for that is because, and PISA supports rich types. It doesn't just understand uint256. It understands strings, bytes. It understands interactions, classes, participants. It understands arrays, maps. And it understands very rich types. And it has methods, standard library, a really complex cryptography library, and so on. Right? So all of this is done with the PISA runtime, obviously. And for it to work with MOI, the artifact that you deploy to chain is something called a manifest. Right? So in Ethereum, usually you deploy a bytecode. Right? And when you compile, usually you get two objects. You get a bytecode and you get an ABI, right?
Yeah.
So what we did is this invocation interfaces, the ABI is merged with the bytecode, and all of this is deployed to chain at once.
Okay.
So I'll show you what that looks like. But the purpose of this is that application developers cannot and should not store the ABI along with the application code, right? Because it is basically a potential vulnerability for how people can spoof your ABI, and you might end up talking to the wrong contract or making a malicious call on the contract because the ABI is provided by the application developer.
Yeah.
In our case, the ABI is generated by the protocol and available
Because
on chain.
Most of the times, these ABIs that actually say this is a pure function,
But it's
it might not be a pure function or something like that.
The beauty is now the manifest, when it's deployed on chain, it's fully verified. When we create the logic, we verify. Simple flipper contract that Solidity has, right? It has 443 opcodes when you compile with Solc, right?
Okay.
And the total 633 bytes. That 633 bytes is just the bytecode, not the ABI. The bytecode is 3 times the size. Okay. The generated artifact we deployed a chain contains the execution bytecode for the ABI. If you do this in Coco,
18 opcodes and 471 bytes.
that includes the
ABI.
manifest. The 471 bytes includes the manifest. All right. Because
manifest is actually the bytecode plus.
I'll show you what the ABI manifest looks like. We'll get into that. But when you use the Coco compiler and target PISA, that this exact code, if written in Coco, will generate 18 opcodes.
So this, how do you get the reference, like from the manifest?
You need just a logic ID.
Okay.
If you use a logic, there is a manifest for a logic ID. So when you use it in the front end, if you specify a logic ID, you can. There are ways to store and cache these things and all, but you just use a logic ID and it will go and fetch the manifest from the protocol.
So this one actually kicks one more security vulnerability.
Every single, I've never been much of a smart contract or a the Ethereum developer per se, but I have gotten into it enough to know that I know where the big holes are. Like I'm a big developer experience person. So
okay, so the question that I wanted to ask you was, what was the point that you were trying to make about these ABIs and
vulnerability being removed?
Yeah. So most probably, what I was trying to tell is, this ABI is being provided by someone like that is off chain, and there can be some vulnerabilities in the ABI as well,
or because even malicious content on
like they can say this is a pure function, but in reality it might not be a pure function. It might not have same kind of arguments or so. So there can be trust issues while getting an ABI from the developer. So he can be malicious, he can act malicious, and this can lead to several hacks and all. In the history, this has happened a lot. So it is one of the main.
It's one of the attack vectors.
One of the attack vectors is injecting the ABI. Everything. So one of the things people do is they try to insert the hash of the code, but it's very easy to spoof. It's not something that. Most bytecode, the way they're structured is they have some initial information, then they have a header information, then they have like a directory saying where is what. So in this part of the code, there is this information. Here, there's this. So all the interfaces are here, all the code is here. It's like there are specifications for that, and then all the content. Right. So usually bytecodes are structured something like that. And I realized that as I started rewriting this manifest to fit a regular bytecode structure that Polo is already doing. Polo is already written. Polo's wire has a header in the front containing all the information about the rest of the wire and every information on where each offset is. That's how Polo's wire structure works. So I realized that Polo's efficient packing, basically when I compile this MOI manifest into Polo and it generates 471 bytes, it's as efficient as it already is. Because keys are not written, there are no capitalization worries, no quotes. Because Polo is a strict encoding spec. It's like protocol buffers. It does not have keys, does not have location, does not have all these names, objects. Everything is inferred. Right.
And if we remove this ABI thing from the manifest, so what would be the bytes?
It will be 18 opcodes is nothing, sir. 18 opcodes is so that's another saving, right? We don't have that many opcodes just because of a register machine. So when you have a register machine, in Ethereum, it takes 20 something opcodes to read an input. So let's say I wanted to read the input of bool and then apply. To read the value of bool flips, it takes about 20 opcodes.
Yeah.
Right, I need to figure out the name, the type. I have to go and figure out how much of the data size will be there. I have to go read the data, decode the data. There's a whole 20 opcodes just to do that. In our case, it's one opcode.
Okay.
It's called obtain and specify the slot. That's it. It's the register machines are extremely efficient because the amount of instructions they need to execute is smaller. Now that has a gas cost implication also. 443 opcodes can cost a lot of money. 18 opcodes not so much, right? So of course, each opcode will be more expensive than Ethereum, but overall, I'm sure that you will be having massive savings on your,
that's what matters.
Yeah, so you'll have, so because the opcodes are so small, 18 opcodes, each opcode is a baby, each opcode is about 3 bytes. So if you had just 18 opcodes into 3, that's, how much is that? I'm bad at math here.
18 opcodes into
36 plus
36.
18.
54.
Yeah, 54 bytes is all it takes to just to have the opcodes. Maybe a little bit more for the metadata. Yeah.
So why did you choose to get with this ABI also on the just for this
like you said,
security,
the security
purpose?
purpose that now, the developer, I don't want developers to maintain ABI along with the application. Feels redundant and unnecessary.
Exactly.
Yeah.
Right?
And most of the time, even while developing the front end for these dApps, we'll have to get the ABIs. Like we'll have to.
You will make some server call to retrieve from
Yeah.
somewhere because people don't keep it locally because they need. So simplify the whole process. It's on chain. Just a simple RPC call, anyone can retrieve. Just need to know the logic ID.
And because of this, most of the developers are not able to actually call so many contracts because if the contract is actually verified on Etherscan, only then we can get the ABI.
Correct.
Otherwise, there's no source to actually get the
ABI
ABI.
is actually uploaded to Etherscan. And
Right.
Etherscan people work to verify that the ABI is valid with the thing. So you need to make a call to Etherscan to get the ABI. You have to rely on trusted third parties rather than just the protocol. So we remove the problem, just query an RPC call. So you can make this today. If you know a logic ID, you can just go to Voyage in remote procedure call, and then there'll be something called get logic manifest, and just specify the logic ID and what encoding you want, and you can either get in
Even with the function name, as you said.
you'll get the full readable manifest.
Yeah.
So the beauty is the manifest. If you get the Polo version, you'll be unreadable. It's pure data. But if you want readability, you can ask for it in JSON, and you'll get a clear JSON file showing you exactly what the ABI looks like. All right.
Can we see an example?
Yeah.
Let's go into that. Right. So I'm going to go and open my Flipper contract. Okay. So I have to do a couple of things. So let me just actually really quickly finish this deck so we can just close this deck off. All right. The deck is nothing else left on this.
And we'll get to it in a bit.
Simple Flipper. Yeah, getting started with Coco. So to install Coco, so all of you, I'd recommend you start here. Go to www.coco browser. Yeah.
Browser.
Just open Arc or Chrome, whichever.
Where is that?
Chrome. Just open a new tab, cocoland.dev. Yeah, just hit cocoland.dev, and on top you should see an install section, right? So I will do that myself here. So cocoland.dev. Head over to install, and there are instructions to follow here for installing. We're obviously all on here. All of us are on Mac, so we're just going to follow the Mac installation. If you are on Windows, you can just download the installer. So like on my screen, I'm just going here. So you head over to releases, and first you want to install the latest release, right? So the current latest release is 3.3. 3.4 is coming out on Monday, and add support for what is 3.4 add support for? Reversion opcodes. So you can use hard resets. You can specify revert instead of just throwing an exception.
So I need the tar file and the MD5 hash for ARM64.
You don't need the MD5 hash, that's just for verification, but
That's okay.
yeah. So
The
all of us
ARM64
are
version?
on ARM64, macOS ARM64, okay?
That's the MD5
So,
hash. And
this
the
one, right?
MD5.
3.3 and this is macOS ARM64. Click on the tar file.
This one.
Yeah, and it should have automatically downloaded it.
Okay.
Okay, so that's cool.
So these would have ended up.
So you head back to install. So once you're down, it should be downloaded now. Just click your downloads here. It's downloaded. Our file. So we need to go. So go back to install, and head over to install, and then follow the instructions. Right. So we've downloaded the code just now. So the first step is download. Open the Linux, macOS, and WSL. So the first step we just finished, right? So the next step is we want to remove any existing information which we already did before we started today. So you already all cleared up our system. So just head over to the next command. But keep in mind that command needs to change. The version on that command is older. It's pointing to 2.2. So you need to use the current command for that. But you can copy that command and go and make a modification on your shell.
Do I have to do this
You need to
/.coco?
You need to go to the downloads folder. So CD into downloads.
Yeah. You might want to start up a terminal window. Yeah. So that's Unix. Just go to CD downloads. I think it's called download. No, it's called downloads.
Okay.
Yeah.
CD/downloads.
No,
CD.
CD downloads.
CD and then just hit it down.
What is the version?
For the, sorry, go ahead.
0.3.3.
It should be 3.3.3. 0.3.3 is the latest version, yeah.
So after this, after going to downloads.
Yeah. Now go over to your command. Go over back to the install, like the install tutorial. Just copy this command.
Okay.
Head back to that. Paste this. Don't enter. Just paste command V. Yep. I don't think you.
Not control.
Okay.
That's the problem.
So,
with
and then
Mac.
just scroll back and just change this to 3.3 instead of 2.3.
3.3, right?
3.3.
And the file name also.
One of the things I recommend now is you head over to the extension for the VS Code and search for Cocolang. So you just search for Cocolang, you can check it out here, and you should see an install plugin available.
Syntax highlighter.
Syntax highlighter. And so if you notice now, my syntax file here is fully highlighted, right? Just for illustration purposes. Let's delete this as well. Delete.
Do you have a file open?
Which way?
Like that's empty, right?
Yeah.
Yeah, there's nothing. So now open a folder, like you do the usual thing, open a folder, create a new directory. You can do this now.
Open a new folder. Let's say folder Coco test.
Yeah. Okay. So I have a empty directory as well. So we're all here together. Okay. Yeah. So before we started that, the first things you want to verify is you want to run Coco version. And
just open it anyway.
What is this now?
Yeah.
Problem.
Perfect.
Right. So we want to run Coco version is not working for me either. What is this new nonsense?
How can we open the terminal actually?
Control tilde.
Okay, control.
Run Coco version. So are you able to run Coco version? And
Yeah.
you should be able to see.
Version,
I
right?
seem to be having some issues.
Coco slash.
Coco version. It's a
Space
command.
version.
Coco version.
Yeah, so it does 0.3. Yeah.
You seeing 3.3? You're seeing 3.3
Yeah.
Okay, let me solve my problem. CD ZHRC smooth path.
There's no space after the slash, sir.
Mm-hmm.
No space after the slash. Coco slash.
Control X, save, enter, done. Okay. That cool. Alright, back on track here.
I like the fact that
What is
what is no, we're getting to it.
Alright, so now when you do Coco version, I'm getting version 3.3. You can see the figlet here. Great. Sort. So similarly, we also want to do Logic Lab version and confirm that that's also on version 2.3.
Logic.
What is it?
version.
I'll show you.
Just Logic version, right?
Logic Lab.
Logic Lab.
So when you install Coco today, you get two binaries. You get Coco and Logic Lab next to each other. Logic Lab is our testing suite. It's how you can deploy to. It's like Truffle Ganache. You can deploy the protocol. You can deploy manifest and test it, create participants. Logic Lab is one word. Sir.
Okay,
Logic Lab is a single binary. It's
Logic Lab.
space version 2.3. So we're all set up. We have our thing ready to go. Okay, so I'm clearing my thing. You can see my screen now, right? So the first thing you need to do is set up your project, right? So you want to do coconut init, and then we're going to write a flipper contract. So coconut init flipper, right? Coco. Then we have a hyphen there unnecessarily.
Coco nut
init flipper. Space flipper. You can use a capital F. That's your module name, right? That's the module you're going to be using. To capital F. What's the issue?
Coco is calling, so I'm just going to text him.
All right. So
Give me a second. No?
I'll crop all this out.
So this one is the package, right?
This is the package or JSON file, or your Go mod file, or your sorry, I don't know if Solidity has something like that, but it's like your package JSON file, right? This is how you manage dependencies, all that stuff, right? So your coconut init file is going to set up, and this coconut file will create a simple toml-like file, and it specifies what version of Coco you're using, what's the module name, what is the version of your module. You can set the licenses and all that, right? So, for example, I'm setting this. This is my first version of my code. I'm going to be using the MIT license for this.
Like we have npm init.
Exactly. npm init will give you a package JSON file, very similar like that, right? The notable parts here is you can specify the OS is MOI and the architecture is PISA, right?
OS is MOI,
OS is MOI, architecture is PISA. Tomorrow we could be targeting, real world, normal Windows machines, Mac OS machines also, and architectures can be x86, ARM, and so on. And the target on the MOI target, we have the formatting. So you can specify what format you want your manifest in. Manifest can be YAML, can be JSON, and the output specifies the name of the file. So
that manifest will look like that JSON or YAML.
You can say the output of the JSON manifest will be a JSON file.
Okay, fine.
All right. So the YAML file will generate. The output is the file name. So this will create a flipper.yaml file. Into JSON here, this will create a flipper.json file. If I do this, it will be a flipper.polo file. Right? Or I can change the name. This will determine what my file output name is.
Yeah.
Right. So in my case, I'm going to stick to YAML because I like the readability of YAML. Right. And the target for PISA, I'm specifying the code format is in. Even that you can change. I'll show you that, but we'll keep this as is for now. So now I have this file. The next thing I want to do is create a Coco file. So I'll do touch flipper.coco. Again, this touch is a Mac OS command, right? I'm sure you guys know this. Linux also does. Touch flipper.coco, right?
Is there a difference between going caps or no caps?
On your file name?
Just depend on your file system, right?
The file extension should be small, .coco. Otherwise, the thing won't enable it.
Okay.
I might have to restart.
Touch flipper.coco should create a flipper.coco file.
My extension is acting weird. Go and fix that. So my extension is now kicked in. So I will have syntax highlighted in coconut file. You can see we're using. So you guys should also have, if you're not seeing the icons, it means the extension is not loaded. You might want to close and restart VS Code.
So this one, right? You said
yeah,
there should be an icon.
So you should be seeing the Coco icons next to the files.
Yeah.
You're saying the thing? You're fine. You?
I'm also seeing the.
Okay, so you just do Command Q.
Command Q.
Q.
And relaunch.
And now just click VS Code. Just do Command space and type VS Code. Studio Code. Click on that. And now go full screen and you should be good. Okay. So now your icons are activated. That means the extension is working. All right.
Right.
All right. Cool. So I have a file here. So the first things I'm going to do is just for my own reference and so I don't lose this, I'm going to hold on to this. Okay. This is my code for later. Crop all that out. Okay. So the first things you have to do when you open a Coco module.
How can I actually get it full screen?
You just tap on the top bar twice. Yeah, tap twice. Or you can do Command M. So
too many commands to learn for a new OS.
Okay. So the first thing when you write a Coco module is you want to specify the module name. So this is the name we specified when we created the coconut init file, right? So this was the module's name.
Okay.
All files in the same directory must have the same module name. So you can have multiple files, Flipper Coco, and you can have multiple modules, Flipper Coco, aux.coco, and have more. But all of them have to have this thing in the top, Coco Flipper.
Is it case sensitive?
The module name, so you can have it caps or small, but it has to match the name of the module in. Ephemeral state. So we're going to define a persistent state. So you use a state keyword and define the persistent accessor, right?
Okay.
So this defines the persistent state object, and we define the structure of the state persistent now, right? For in our case, we are going to use the word. Let me just Command C. Okay. So we have a variable called value. It's a field in the persistent state, which is of type bool.
Or should I? This one is indented, right? So
Yes.
Yeah.
That's why I'm not even familiar with this indentation also.
Python. It's all Pythonic.
Yeah.
Okay, that's good. We have a good mix here. Okay. So
It's like structure.
it's like a struct. It's like a class almost. So, and this is the class is called the persistent state.
I'll have to double check every time.
No, don't worry about it for now. We can come back and we can
exception,
when we compile it, it'll give compiler. So we should be okay, right? So we have a persistent state right now, and probably the first thing we want to do is write a deployer, right? So we can write something very simple, right? So for example, for us, when we have there are functions and there are endpoints. Okay, endpoints are the things that you can call externally.
Okay.
So from externally the contract. Functions are used within the module to have reusable code. So endpoints cannot call endpoints.
Okay.
But functions can call functions and endpoints can call functions. Okay. So when you make a function call, you're always calling a function. An endpoint is simply a function that can only be called from outside the logic.
Okay, like kind of external.
External. Okay. It can only be called externally. Meaning internally, endpoints cannot call endpoints also. So it's like almost like if you write a REST API, it's like your get method. You will never use that get method internally. The logic of the get call will be somewhere, but the exposing of the get call will be somewhere. Right? It's like the place where you expose your code logic. Right? So if I want to write a deployer endpoint, so I do endpoint, and then I do deployer, and then I could have a deployer called init. Okay.
Deployer.
Any reason why deployer is not capitalized but value is?
Value is a variable.
So
Okay.
all variables are capitalized.
For now, because today we don't have export rules. So usually if it's capitalized, it means it's exported or a global variable.
Got it.
Or if it's a thing, but in state, it doesn't matter.
Got it.
Okay. So endpoint, deployer, init. Notice that for init, I use an exclamation mark. Okay.
Yeah.
Just keep in reminder, and I'm going to come back to you in a bit and ask you why you think the exclamation mark is there. Okay.
So what you said is endpoint is like an external.
Endpoint means it's a function that can be called externally.
Externally.
Correct.
Yeah. And
There are 4 types of endpoints, but today we support 2. One is deployer, other is invocable.
Mhm.
The 2 others we don't support right now is enlister and interactable.
Is it like events?
No. So an endpoint is like your external function. So for example, if I wrote a function, so let me give an example, right? Let's say, okay, just for your benefit, I'll write something simple here. I can have a function called funcdo, right? And funcdo has, let's say, it does something. Right? Don't worry about what. Now, when I do this, do is not a function that you can call from your contract outside. You cannot specify that I want to call do.
yeah.
Do all functions are internal.
Is internal.
Right? But from inside an endpoint, I can do the do function now.
Okay, yes.
Right? And I can use that for any function. Functions can be used, functions can call functions, endpoints can call functions. But endpoints are
Cannot
your
be.
exposition points. Like it's the point where you're specifying this is a
Endpoints.
valid call site. Which means
They are like endpoints, right?
they're literally the word
Yeah,
endpoint.
the endpoint. Yeah.
The word endpoint is supposed to kind of just make it clearer. It is a place where you specify where your contract's interfaces are. How
Okay,
can you interact with the contract, right? So you have 4 types of endpoints because you have 4 types of call sites. One is your deployers.
You cannot write the logic inside it.
You can write logic inside it. The logic, you can write whatever logic you want, and you can use functions to abstract the code.
Yeah. But
Right.
for me, it looks like it is outside because we have that curly braces in that. In
Yeah,
JavaScript.
it's
Now
a-
that's
it's a
why
Python.
it does look like it's not inside it.
Yeah, I guess.
So
if you get
indents are basically curly braces. You have to like get.
so once you open a colon, it's like opening curly brace. Once you unindent
Okay.
The curly
Once
braces.
you what is it?
that indentation, you see that colon, right?
The
Yeah,
colon
yeah.
is
Okay.
The
basically.
colon is there, and
Okay.
you indent, it's the open of the curly brace.
Okay, fine.
So this is if I wrote
And
this
where is the close actually?
when you unindent. So this is essentially equivalent to,
Writing.
I mean, depending on your style,
This is that. Yeah.
Okay. Whenever you unindent,
unindent square bracket. Okay,
otherwise I won't be able to
Python
understand.
probably.
Only.
it's a Python. It's just a Python.
Yeah. If you've written Python once, it comes.
But once you get used to it, this is way more readable because the curly braces are unnecessary characters in your readability. Right? So anyway, so the first part is you can have these endpoint deployers, which are essentially, if you're in Solidity, constructors, right? But the beauty you'll notice here
Yeah,
is
now I got it.
the beauty of what you can do now is these are multiple constructors.
Okay.
So you can have multiple constructors you can define. The beauty is today, if you go to ERC20, most people just copy the OpenZeppelin ERC20 contract
Yeah.
and they just deploy the same thing again. But OpenZeppelin, if they're going to be the contract standard manager, they can just write bunch of constructors. And depending on your use case, you can construct appropriately. So for example, in my case, I deployed 2 constructors. For such a simple use case, I can have a constructor that either does nothing, which means the value will default to its 0 value, which is false. Or I can take a constructor called seed,
Okay.
which will take an input value and set that as the initial value.
Okay.
So I can have multiple constructors. You can only use them once.
Okay. In there, we'll have to at least have something to start with.
So you can choose any kind of logic. You can take a
Initial
string. So you can take a string and then you compare whether the string has a certain length and only then you'll set true. You can have some weird convoluted logic, right? But the point is you can have multiple constructors defined, but you can only use one. The first time you deploy the logic, you can define which logic you want to use.
Got it.
But the beauty is someone like OpenZeppelin can write a contract with multiple constructors that different users can just copy, paste, reuse. They never have to change the code. OpenZeppelin can just define multiple constructors for you to initialize your contract in different ways.
Okay.
Right, so multiple constructor support is commonly requested in Ethereum. So we thought we'll do it. Right, it's quite easy for us. So we thought we'll figure it out. Right, so we opened deploy. So we have 2 constructors we just defined, init and seed. Right, now let's write our first invocable function. Right,
I'm not.
yeah, go for it. Just copy.
I'm not able to select this. Not able to think. Or not like this. Like I can.
Okay, so
if
you need to use one finger, press down, and then use other finger to select.
Okay.
Oh, okay.
It's intuitive for us,
Yeah,
but people get used to
I
it.
forget. Like, yeah. What is the seed thing doing? It's doing a set.
And let me just 1 second, quickly. Sorry, I'm adding 2 functions here now so that it simplifies our thing. Wait, hold on, guys. I'll just give you what you need to do. So just don't write the commented code. Just write the uncommented.
Muted.
It's part of the seed function. Okay.
Yeah. Don't write the uncommented code for now. The commented code, don't write it for now.
So you're mutating not value capital V.
So this code is correct. So like
Okay. Yeah.
So let's kind of try to understand what's happening here, right?
Yeah.
Before you go too deep into this.
Sure.
So value is the name of the variable.
Value is the name of the variable in the state. So usually in Solidity, we use underscore and use a value to represent it's a state variable, right? In our case, to access that variable, you have to do flipper.state.value.
Okay.
It's correctly
Like this
encapsulated.
dot something.
Yeah, flipper.state. The beauty is, this is just because you want to access persistent state. Imagine you wanted to access ephemeral state. You need a different way to access those, right? So you can do sender.state.value, state.value. Cool. Okay. So let's go through the first one, right? So the first thing is let's look at the deployer seed, the seed deployer, right? It needs to be capitalist.
But it was giving this.
Yeah, that's just it's not like the VS Code extension is still quite early. It's not fully mature. And even here, the V value wants to be capital because that's the variable here.
Oh.
Okay. All right. So we're all caught up on the code? Okay.
Yeah.
So if you look at the first deployer, right? The deployer seed. So if you notice deployer init, we're not doing anything, right? It's just pass.
Yeah.
Which means the constructor never constructed anything on the state, but the value is a boolean, so it has a default false value, which is the 0 value of bool, which is false. So if you just do pass, when you do init, it will do nothing because you need to specify a call site. The call site is the name of the function, get seed init.
Right.
Okay. So when you need to specify call site, if you don't want to give any input, you just want to initialize the constructor, you can use the init. Okay. So when you use init, it automatically creates a pass, and you can then use seed as an alternate if you want to give some input to what the initial value should be. Now let's look at the first line number 10, right? Deploy.
Those are not keywords, right? Just the names.
Which one? The seed, not?
Yeah.
Yeah, those are just the function names that you can use. You can use whatever name you want.
Can you
Which has a type string.
Okay, fine. So this state persistent is the area where we declare all the state
Declare all the
variables.
struct, and you usually do contract, but you have to declare all the state variables in the state persistent area at the top.
Yeah.
Right? And if you want
there we can actually declare state variables wherever we
freely
want,
anywhere
right?
else in the contract module.
Yeah.
But this is prevented here. You have to define everything in the state object, within the state indentation.
Okay.
Inside state indentation, whatever state fields you have,
This one is like struct, right?
It's just like a struct.
Okay.
So let's say you wanted to have a thing called my map. It's a field, right? And that my map can have a map of string to U64.
This isn't supported there, right? In struct.
Yeah, in struct you can't have maps in struct in Solidity. Yes, right. But in your contract in Solidity you would have written this as something like this. I'm just trying to remember my Solidity here. But I would have something like contract, and I would have underscore value bool, and then I would have underscore ABC is type string, and I have underscore my map would be mapping of
It's just opposite. Yeah, somewhat like this.
yeah.
It would be bool value, not
Bool underscore. Okay, I'm sorry.
Yeah,
This is just
Yeah,
the
fine. It's true.
go syntax I'm used to, and then you have something like U in 64, right? Something close to this is what you'd end up with your Solidity contract. But the thing is, you could technically between this you could declare a constructor. It's valid. This is valid syntax.
Yeah.
You can declare a valid constructor here. You can write a constructor, open the thing, write some code for that. But all the state variables are all over the contract module.
Yeah.
Here now, let's say think about this. My perspective always is the auditor. If I'm an auditor, I want to come and see all the state variables you have access to. I have to sit and find underscore variables.
Yeah.
Or I have to do some weird tool to find all the state variables and stuff.
Most of the time it will be on the top, but it's best practices.
Again, underscore is the best practice. Keeping on the top is the best practice, not enforced by the language.
That is
right. That's my one gripe with Solidity is a lot
It's
of it.
not just a struct, but it's a place where like all
State
the
variables.
It's a place where you declare all your
Predefined.
person state variables. The reason we also have this is because you could potentially also want to do some ephemeral stuff, right?
Okay.
These are ephemeral state values
Got it.
that you want to store.
Okay, fine.
Like so, in a given module, across all the files in the directory, you can only declare one persistent state and one ephemeral state.
So this ephemeral state is the state of this contract.
It is persistent is the state of the contract. Ephemeral is state of its users.
So how
Locally
can
also we can define the variables, right?
but
Locally.
how can it
You're defining
store?
the structure of the data. You're just defining what this data looks like, not the data itself.
Okay,
right?
okay.
You're defining just a struct. You're not defining the object.
Okay, fine.
Right? That object is stored on the participant, but you want to define what is the schema.
And this
of
is
that
for
object.
ephemeral, right?
Yes.
For persistent, we'll also have the
We can
data.
store the data also. The data is something that you store over the code over time. But the ephemeral state is something stored on the participant storage.
But we have the data type and
The
all
data
those
type,
things.
everything has to be specific because the schema of the state
Yeah.
has to be specific, right?
Okay.
Right. So,
Locally also we can define variables, right?
and you say locally, yeah, that is you can use var and declare. So we'll
Yeah.
do that, right? So I'll show you. Like when you have a simple function, you can have. So let's say I have a function called do. You can ask me very basic syntax stuff if you question. But let's say I wanted to have a boolean, so I could have a var a bool. I can do a equals true, right? And then I can do a equals not a, and b equals the comparison between a not equals a.
Okay.
Okay, this would obviously be a stupid comparison, but if you wanted to, right? You could also do a equals invert a, whatever, right?
Not
When you're dealing with bool, so you could all all this stuff works the same way.
we have var and
You just use var.
just var.
So var, declare a variable, declare a type.
Got it.
Right? And there are other ways to declare variables. You would use the make statement to create maps, arrays, sequences, and you can use the build keyword to create custom constructors and classes.
Sure.
So if you had a class called person, you could do build person, and then give any inputs you want to give. Okay. And make is basically like if you wanted to make a string, you can use primitive types also, or you can do make map of this type with 10 size, something like that. You can specify some sizing and around that. Sizing is for arrays. Okay.
Why are we using this exclamation mark after the name?
Yeah, we'll come there. So just I'll go through this and you'll try to tell me if you were able to figure that.
4.
Okay, so line 4, we have a state persistent. We have a single field called value of type. So our first deployer first constructor we have is called init.
Okay.
Init has an exclamation mark and it just pass, meaning nothing is happening in this function.
Okay.
Right?
Just pass.
Yeah, just pass meaning this value of there is no data for the value field. State flipper.state.value has no value in it.
Okay.
Which means it defaults to 0 value. There's no nulls in Solidity in Cocoa.
That is actually false, right? Then
It's automatically false. The 0 value is false. So if it was a string, it will be an empty string. If it is bytes, it will be empty bytes. If it is U64, it will be a 0. U20 will be 0, right? So it will default to 0 values. There is no such thing as a null in Cocoa. All right. So empty means 0 value. Okay. So you got to keep that in mind. So when you do deployer pass, it just leaves the value as is, which will just be no data, which no data equals 0 data equals false. So the endpoint deployer seed, if you notice, takes an input called init of type bool. So it's a one input it takes, which is of type bool. And what can we take a look at line number 10 and see what's happening? Just take a guess what's happening in line number 10.
value.
Yeah, it's init, not value.
Take a guess. What's happening in line number 18? 18?
Init should be actually set to value.
What has happened here? How does that look like 18? Are you guys seeing 18 too?
Yeah.
It is actually 10.
It's 10, but I think the screen is just
Actually,
completely screwed.
There's a line.
That line in 0 is looking
hard.
crazy. Okay.
Init
okay.
is there. Actually muted in it.
Okay, take a shot. Tell me what you think is happening in line
So
10.
value is actually this state variable is being set to init.
Correct. So you're creating a mutate statement and you're taking the value of init and setting that to the value. So notice that get. So if you let's look at the next function, invocable, right? The get function.
Okay.
First note I want to make is get does not have an exclamation mark.
Yeah.
Okay. Then you notice that get does not take any input, but returns to you one boolean.
Yeah.
The first thing in Coco, the rule Coco, next rule Coco is when you have output variables, every output variable has to be named. This is not valid syntax.
You can't say just it returns some bool.
You can't just say bool. The bool has to be named. It has to be named. So if you're returning multiple variables, you have to do value comma bool and 2 comma bool again, whatever. You can have that. You could remove the bool if you wanted to, because this will understand. Value 1, value comma value 2, both are type bool. This is Go syntax. Okay. So we can do this, but in our case, we just need one output, so this is that. What is happening in line 13?
Line 13.
Like the value is being returned.
Yes, it's being observed. Okay.
The flipper value actually comes from there.
Flipper.stated value into your local variable called value.
Yeah.
But notice local variable value is also your already pre-declared output value.
Yeah.
So now you don't return. It's just set.
Okay.